This video is going to talk about how to make a tree diagram. A tree diagram is used to show all the possible results of more than one event at a time. So, for example, let's say I was going to flip a coin and roll a six-sided die. I start off with no possibilities. Nothing. Just a little dot. When I flip the coin, all of a sudden there are two outcomes. I could get heads or tails. So right now I have two outcomes. If I get heads, then I roll the six-sided die. I could roll a 1, a 2, 3, 4, 5, or 6. That's if I roll heads. If I roll tails, I could still get 1, 2, 3, 4, 5, or 6. Now I see that when I start from nothing, and then I flip a coin, and then I roll a six-sided die, I could get one of 12 different options or outcomes. If I roll a 2, I might have flipped heads or tails. If I wanted to know what is the probability of flipping a coin and landing on heads, rolling a die and landing on 4, I have heads, 4, I have a 1 in 12 possibility, because only one of these options are flipping heads and landing on 4. This is heads 1, heads 2, heads 3, and so on, but heads 4 is the one I want. So that heads 4 has a 1 in 12 probability. But what if I wanted to flip a coin and get tails and then have an even number when I roll my six-sided die? None of these options count anymore because I want to know what happens when I flip a coin and land on tails. So I'm only looking at this part of the tree. Then I want to know, well, I want to get an even number. Is 1 even? No. Is 2 even? Yes. 3? No. 4? Yes. 5? No. 6? Yes. So my probability of flipping a coin, getting tails, and then rolling an even number is 3 out of 12. And don't forget that you can reduce that to 1/4. Now you might be wondering, well, how can I see all of the different outcomes, but I don't want to use the tree in my final answer? Off to the side, I'm going to write out all of the different outcomes and hope that they show up in this red marker. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. I could also get tails 1, tails 2, tails 3, tails 4, tails 5, or tails 6. So there are all of my outcomes. And it doesn't have to be two different events that you're talking about either. I could look at driving down the street in my little, well, it kind of looks like a space car, but whatever. Driving down the street and pulling up to 2 stoplights. when the car gets to the first stoplight, right now there's no lights, when it gets to the first stoplight, it might hit 3 different colors. And we all know that those colors are red, yellow, or green. Regardless of what color it hits when it lands here, it will eventually go on and hit the second light. The second light, no matter what color the first light was, could be red, yellow, or green. So the driver of this car, who's waving at you, wants to know what is the probability that the driver is able to go past both of these lights and have them on green. Well, does this count at all over here? No, it does not, because this is a red light and we only wanted green. Does this count over here? No, it does not. We only wanted a green light. Does this count over here? Yes, it does. That's part of what we want, but we want both lights to be green. Will this light be green? Nope. So that doesn't count. What about this one? Nope. This one? Yes. So we have a 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 1 in 9 chance they will both be green. What if the driver really doesn't like yellow lights, and the driver wants to know what's the chance that the driver might go through and hit a yellow light? Doesn't matter which one it is. The driver wants to know what's the chance there'll be a yellow light. Well, here's a red light, but we don't know that's only one light. We want to see what happens about the other light. Is this red? Is this yellow? Nope. Is this yellow? Yep. Is this yellow? Nope. Let's look at our second light. Is this a yellow light? Yes. And because the driver only wants to know about one yellow light, all of these count, because no matter what these options are, the first light was yellow, and that's all that matters. Let's look at the third light, which is green, which means we still have to find a yellow light. Red is not yellow. Yellow is yellow. Green is not yellow. So we have a 1, 2, 3, 4, 5 in 9 chance of one yellow light.